Okay, we're going to do one of the application problems here. We're going to look at problem 4.1. Okay, this is on page 174. And I'm going to go underneath our camera here. I have the problem statement right here. So it says that we have a beam here. It's loaded as shown. We want to determine the reaction at A and the tension in the cable BC. So it's telling us that it's a cable. So there are two supports here. The first support is at A, which is a pin support. The second one is at B on this beam, and it is a cable that is then running down to C. Okay, so first things that we're going to do, we'll deal with the reactions and what we're going to put there in just a little bit, but we're going to start by just drawing our free body diagram with the applied loads and the distances that we see here. So I'm going to start my problem off as we always do. We're going to say this is problem 4.1. We're going to put our convention in the upper right-hand corner for this problem. And remember, you're starting problems on a new page each time. Just easier for me to see. Sometimes I miss them if they continue on. All right, so now what we're going to do is we're going to draw that beam. So it's just going to be a horizontal line. Okay. We have the end here is going to be B. And then we have a little ways in, right? I'll add the label A after I get my forces in place here. I've got 1, 2, 3, 4. Okay, so out on the end here, we've got 15 pounds going down. So this is 15 pounds. Then I've got 20 pounds, a little bit larger. Then I've got 35 pounds. Going down. And then at A, I have 20 pounds again. Trying to get the same height. So it looks proportional. And then at B, I've got 15 pounds. So all of those external loads or applied loads. Okay. This is point A. Now, distances, I know this to be 6 inches, 8 inches, 8 inches, and 6 inches between. So applied loads, distances, my 2 points, A and B. Now what we're going to do is we're going to add those reactions at the supports. So A, as we know, is a pin connection. So if we look back to page 160, a pin, which is here, has two reactions, an X and a Y. So at A, we're going to show an AX and an AY. So I'm going to put my AY going vertical. I'm going to show it pointing up because all of my forces are going down. This needs to support. So I'm thinking up is going to make sense. And then I am going to have an X-directed reaction at A. I'm not crazy about this. I'm going to have to move my 6 inches. So this is going to be my AX. I'm going to move A to the other side here, and I'm going to put my 6 inches above. Okay. So you have to have two reactions here at A, AX and AY for that pin. B is a cable. Now, if we recall from our guided notes, I guess I'll show you the pin. The pin was the first one on the first page, two reactions in the X and Y direction. A roller is one perpendicular to the surface, and our cable is one along the line of the cable, pulling away from the body. Okay, pulling away from the body. So my body is the beam. So it's going to go along the line, which it's a vertical cable, and it's going to pull away from the body. Okay, it's going to be in tension. So B, Y. All right. Cable always has to pull away from the body. It always has to be in tension because if it's not in tension, it's not supporting, it's collapsing. Okay. All right. Do we have everything that we need here for our free body diagram? I think we do, huh? Feel good about it? We do.
Okay.
All right, so now step number 2, we're going to use our equations of equilibrium. Okay, equations of equilibrium. So we'll start with sum of the forces in the x equals 0. There's only one force in the x, and there is a force in the x, so you have to write this out. So we have ax, we assumed it to go positive to the right, equal to 0. Put a box around ax. That's its value. It is 0. All that says is it doesn't have to support in that direction, but we always put it in, okay? Because it is a reaction. It's letting us know, what we have to plan for in that direction. All right, then the next one we're going to do is sum the forces in the y equals 0. So as we look here, we're going to go left to right. We've got a negative 15 pounds, negative 20 pounds, negative 35 pounds. I'm going to go with the applied loads, negative 20 pounds, negative 15 pounds. I've got a positive AY, got a negative BY. There's a lot, is equal to 0. Those are all of them. So make sure you get them all in there. So now that means that we can combine all 5 of those. So that's 15 plus 20 plus 35, 20, 15. So do you get 105? Does that make sense, right? So we've got a negative 105 plus AY minus BY is equal to 0. I'm going to move that 105 to the other side. AY minus BY is equal to 105 pounds. All right, that's as far as we can go with that one, right? But we're not worried. We've got one more equation of equilibrium, don't we? We have sum the moments, all right? Sum the moments. Sum the moments. What do we want to sum around? Our 2 unknowns are AY and BY. Should we go around over on the end here? No, Jesse says, nah, no. We want to go around one of 2, which ones? A or B? Excellent. Yes. So you want to do A or do you want to do B? Nick, I heard Nick first. He said A. We're going to go around A. It takes care of those guys, right? So go ahead and write your equation to sum your moments around A. I'll do mine here and we can compare. Before I go further, I just want to double check. Did you guys get 840 by combining all those values? You had to have a negative 15 times 6, okay, and a negative by times 6. Because you kind of go to the other side here. It goes in a clockwise direction. So it becomes positive on both sides. And then I'm going to divide by 6 inches. My by comes out to be a positive 140. Yep. Great. Good, good, good. Well, it's a positive value confirming my negative direction. Okay. All right. Everybody get, it looks like I've got a couple yeses. Good. Okay, awesome. So 140. Now we can take our by, we can substitute it back up into the sum of the forces in the y to solve for ay. So we have ay minus 140 pounds is equal to 105 pounds. We're going to move that to the other side. AY is going to be equal to 245 pounds. Right, 140 plus 105, 245. And that takes care of our reactions and our supports. If we go back to our application problems page, 245 for A, up, and 140 pounds, that must be for B. And that one is actually going down, but we confirmed it. Good. Any questions on that first problem? Good, 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 good. All right, I'm going to stop the recording here.